A bar cross B bar equals to AB sin theta n cap. A bar cross B bar equals to AB sin theta n cap. Before going to explain about this concept, I want to explain one basic example. I have taken a block on the floor. I have taken, now I applied force on it. Force on it, what will happen? It will move forward with an acceleration. This one we know very well. But when we are coming to the cross product, here this force is acting in different way. Let me explain best example for the cross product. Here pushing a door. Here door is there, right? Door connected to the hinge here. Door connected to the hinge here, right? Along the door I have taken R bar. R bar is the vector. From the hinge to the handle I have taken R bar. If you push the door horizontally, what will happen? Nothing will not happen. Horizontally, if you push, what will happen? Door will not open. If I apply certain angle, what will happen? Door will open. If I apply force with certain angle, it will open. Now, if you want to push the door easily, where I have to push? If I push here now, it will take more force to move the door. If I apply force here, somewhat than that easier. Here if I apply, easily we can move. Here if we apply, easily we can push the door. What is the meaning of it? When we are coming from the hinge to the handle, our task will be easy. Now what is happening here? Horizontally, whatever you are applying, it is not useful. With certain angle, it is useful. And if I apply perpendicularly, what will happen? Easily I can open the door. Now here we have to understand one point here. R bar along the door we have taken. Now I am applying force perpendicularly, perpendicular direction. Means, for example, this is x-axis, hinge axis y. You can consider hinge axis y, horizontal direction. You can x-axis. You can take R bar position vector. Now I am applying one more dimension, or else one more system. What is that? Z-axis. In the z-axis, I am applying force on it. Means perpendicularly I am applying. What is happening here? There is a turning force. Usually, if you apply force on any object, what will happen? It will move forward. Means straight line motion we can see. But here what? Which motion we are seeing? See, when we are applying force on it, it is turning, right, with an angle, and circular motion we are observing. Circular motion we are observing. See here, when I am applying force, the force is giving the turning effect. The turning effect is nothing but torque. The turning effect by the force is nothing but torque. That torque, how it will be? Now I said horizontally we have taken position vector R bar and applying perpendicularly force. Now the torque is along the hinge axis or axis of rotation. For example, if you want to rotate anything, it must and should be a axis. That is the axis torque. Torque is not a motion. Torque causes the turning motion. Torque is applying along the hinge, along the rotation of the axis. There is a circular motion. Motion should what? There will be an axis. That axis, along the axis, torque will be applying. See, this is like z-axis applying force horizontally, x-axis position vector. Now y-axis perpendicularly torque direction is coming. Based on the door example, I am going to explain about cross product. Here I have taken coordinate system x-axis, y-axis as well as z-axis. X-axis horizontal, vertical, y-axis. Z-axis is representing towards you. Towards you is nothing but it is showing like this, your direction. This is z-axis. Now I am applying or else I am taking R bar position vector along x-axis. Along x-axis I have taken with an angle. With the z-axis I am going to apply force, that is F bar. With horizontal, with x-axis theta I have taken. How we can represent? We can represent this is the z-axis. Z-axis, right? X-axis, z-axis. With an angle now force we are applying. This is the thing. What is the meaning of it? This x-axis to the force is the theta. Means I have taken in between the angle. What is that? x-axis, z-axis, perpendicularly applying. If you apply perpendicular, now door will move, right? I am applying force with an angle with x-axis, right? This is making theta. This force I can resolve into two components. Along x-axis, f cos theta. Along z-axis, f sin theta, right? That is I am going to do. This f, right, with making x-axis angle theta. When we are resolving horizontal component, this is f cos theta. This force is making with z-axis. That is nothing but what? F sin theta. I hope clear. F sin theta. Now this f cos theta horizontally applying. Door is, if you push the door like this or with certain angle, it will move. But when you are applying horizontally, it will not support to the rotation of the door. So that this f cos theta here we are not taking. Why? Because it is not supporting for the door to rotate. But if you apply force on it, door will rotate. Means what is applying vertically? F sin theta is applying vertically. So that torque tau bar equals to r bar cross f bar. That is nothing but r is the vector r, right, dot, which is helping here perpendicular. Perpendicular means vertical component is helping. That is what? F sin theta. And we have seen when we are pushing the door is rotating on the axis, hinge axis. That is on the axis of rotation, door will rotate. This is the hinge direction. On this hinge, what will happen? It will rotate. That is nothing but n cap, new direction. This is nothing but tau equals to r bar cross f bar, r dot f sin theta. If you consider a bar cross b bar, that is nothing but ab sin theta n cap. I hope clear here. If you apply parallelly means what is the angle? Sin theta. Parallelly means 0. Sin theta, when it is 0, sin 0 equals to 0. So that torque is 0 when the force is applying parallelly. Torque is maximum when we are applying perpendicularly, means tau equals to rf sin theta, magnitude, right? Here what is the angle? Rf sin 90. Sin 90 means 1. So that Rf, tau is maximum when we are applying the door perpendicularly. Tau is minimum when we are applying parallelly. This is about cross product. Thank you.